Okay, so we're going to try and find the interquartile range. Basically, we want to find Q3 and then we subtract Q1 from that. So we know that Q1 has to equal a quarter and Q3 has to equal 3/4. So because that's our first quartile, that's our first quartile, this is our third quartile. So that's what they have to equal. So from there what we're going to do is we're going to anti-differentiate and let the antiderivatives equal these. So 2y, and then of course solve for Q1 and Q3. So 2y anti-differentiates to y squared between Q1 and 0, and let that equal a quarter. So then we have Q1 squared minus 0 squared equals a quarter. So we've got Q1 squared equals 1 over 4 square root, make it Q1 equals plus or minus 1 over 2. And we know this is going to be between 0 and 1, so it ends up being 1 over 2. And now, for the second value, we have 2y, we're going to differentiate to y squared, and we're going to put that between Q3 and 0, and that equals 3/4. So from there we have Q3 squared minus 0 squared equals 3/4. So we've got Q3 squared equals 3/4. Find the square root, so we've got Q3 equals plus or minus root 3 over square root of 4, which is 2. And once again, we're going between 0 and 1, so we've got to take away so we've got to eliminate the negative. So we end up with root 3 over 2. Now, the interquartile range, we know, is Q3 minus Q1. So from there, we have root 3 over 2 minus 1 over 2, and decimal equivalent, or decimal approximate, 0.8660 minus 0.5, we end up with 0.3660. So that's how we go about finding this quartile range. We have Q1 with our integral equal a quarter, Q3 with our integral equal 3/4. Anti-differentiate, solve for Q1, anti-differentiate, solve for Q3, subtract Q1 from Q3, and that's what we end up with as our interquartile range.